Hello and welcome again. Now in this tutorial, I'm going to implement the reverse operation on a linked list. Now the reverse operation physically reverses the linked list. It doesn't mean only to print the content of each node in the reverse order. That we can simply achieve by using a recursion function or by using a stack. So if you want to just print the contents in the reverse order, then you can use a stack and traverse the entire linked list from the first node to the last node, as we did while printing the linked list or searching in the linked list, and just push the content of each node into the stack. And when you come to the end of the linked list, just pop out the stack and print the elements from the stack there until the stack is empty. You'll get all the contents in the reverse order. That is not what we are doing. What we are doing here, we are just reversing the linked list physically. That means if you apply this reverse operation twice in a row, the linked list is going to remain same. So in order to do that, we'll take 3 pointers and I'll show you how to do that. But first of all, you can see that there in the slide, the first one, this linked list is reversed and we get this one, the second one. Here the head was pointing to this node and tail was pointing to this node. And when we apply the reverse operation, the tail actually now pointing to the first node that was at 300, and the head is now pointing to the last node, which was the last node that becomes the first, and the first becomes the last. And you can see that since this node has become the last node, so the null is contained here because this is the last node, so the next pointer field of this node contains null here. And also each node was pointing to its immediate next node. You can see that 500 is the address of this, 800 is the address of this node. But here after the reverse operation, this node is actually pointing to this one and this node is actually pointing to this one. So the whole linked list is reversed physically. We need to manipulate the addresses in such a way so that we can achieve this. So let's go ahead and see how we can do that. Okay, let us now develop the algorithm for reversing the linked list. We'll take 3 node pointers, P, Q and R. We'll initialize P with the address of the first node. As you can see it there, P is 100. That means it is having the address of the first node and pointing to the first node. And Q is actually the node pointer that's going to point the immediate previous node being pointed by P. And R is immediate next to P. So R will be initialized with the address of the second node and Q with the null because we do not have any node prior to the first node. So this is the initial condition, initial situation there. Now if there is only one node or no node at all, then we do not need to do anything. So we'll be actually implementing this when there are more than one nodes. So let's go ahead and try to understand how we can reverse the links. So there is only one statement. We need to just assign the Q pointer field to the next of the current node. That's it. So P arrow next equals Q. That is going to reverse the link. As you can see that P is right now the first node's address. So P arrow next is actually, this should be right now 200. Okay. So right now this P arrow next, that means this one is actually assigned with Q. That is the address of the previous node. So, and that is null right now because we do not have any previous node right now. So we are going to assign null here. So as soon as you are actually assigning null, this link is no longer there. Earlier it was pointing to the next node, the second node. Now this is null. Now that is obvious actually. Now when we are going to reverse this linked list, this first node will become the last node and the next pointer field of this first node will obviously contain null because that will become the last node. And that is happening here. Okay, now what we need to do after this operation, we need to shift these pointers one node towards their right. That means Q will move where P is right now. We need to move the P where R is right now and need to move R to its next. So after the operation, so let me just write the code there. So these are the shifting operations. Q equals P, P equals R, and R equals R arrow next. So let me just perform these. So Q equals P actually assigns the content of P to Q. So Q comes to the first node. That means Q will be pointing to the first node because 100 is there in Q right now. Now when we do this P equals R, P is moved to the second node. So let me just delete that and redraw the figure there. R is assigned to P. That means P is now 200 and we go to the second node. And R equals R arrow next. R arrow next is actually 400. Okay, so that is assigned to R. So R comes to the node which is having the address 400. That is the next node to P. So now we'll be actually iterating back in this statement. We'll have a while loop there unless and until the P is not equals null. We'll be doing this repetitively. So P arrow next equals Q. That is going to happen again. So now P arrow next means this next field, and that is assigned with the address of the immediate previous node of P, with the address of the immediate previous node of P, and that is currently held by Q, and that is assigned there in the next. You can see that. So this 400 is going to be replaced with 100. That's the content of Q, the address of the first node. So this link is no longer going to be there, and obviously this is going to point this one, and we'll be actually moving these pointers again towards its next, and we'll be doing the same reversing of the links. So in that way it will actually reverse the entire linked list, and at the end, when we come to the end, we'll actually just assign the address of the current last node to head, so that the head points to this current last node, and also the current first node to tail. So the head is going to point the first node after reversal, and tail is going to point the last node after reversal. So that's the algorithm, and let's go ahead and write the function there and see how that works. Okay, finally here is the code for reversing the linked list. You can see there we are checking the node count at the very beginning. If the node count is less than equals 1, we don't need to do any reversal. Otherwise, we are declaring 3 pointers there, as I said earlier. P, Q, and R, these 3 are node pointers, and Q is initialized with null. P is the address of the first node right now, and R is the address of the second node. P is the first node, and P arrow next is the address of the second node that we are assigning to R. So always Q is the previous to P, and R is the next to P. So we are running this loop there. That's an undeterministic loop. We are entering into the loop there, and you can see that we are reversing here. Now the loop breaks when P goes to the last node. As you can see it here, if P equals with tail, then obviously we are breaking the loop. That means we have actually reversed the entire linked list, and we will be breaking out of this loop. So these 3 statements are for shifting the pointers. Each pointer is moved towards their right. So Q goes to P, P goes to R, and R goes to R arrow next, as I demonstrated there with the figures earlier. So when you come out of this loop, then the entire linked list is actually reversed. Now we need to just swap the head and tail, so that the head points to the first node of the reversed list, and tail points to the last node of the reversed list. So tail gets the address of head, and head is actually assigned with P, where P is actually currently the address of the last node before the reversal. So that's it. I mean, let's go ahead and just check out this. I will try to run this. I'll try to compile this and run this. Let me just update the case 11. That's for reverse. I will just call the reverse function from here. And I'll pass the address of the list object. Okay, now let's go ahead and compile this. Okay, so gcc linklist.c is compiled successfully, running the program. Let me create the linked list first. So I'll be using the second option, and I'll just create the linked list with 8 numbers. So now let's see if that is created. Yes, you can see that there are 8 numbers there. Okay, now I'll call the reverse operation. That's option 11, and it has been reversed. Okay, let me show you that. You can see that it has been reversed. You can just print the details of the linked list. In that case, you'll get all the addresses there, and it will check out how the reverse is working there. So that's all. I mean, we have developed all those operations there. Now in the next tutorial, I'll just create another program. I'll take some of the functions from here, and I'll show you how to recursively traverse each node of the linked list. And after that, we'll move ahead and we'll create stack and queue using linked list. And also I'll show you how to build a double-ended queue using linked list. Thank you very much.